Welcome to the physics class. In this lecture, we are going to study basic definitions, and I have switched to OneNote now because this is more convenient to use. So here we go. So basic definitions. First is position vector and displacement vector. Mm, If the coordinates of point A are x1, y1, z1 and B are x2, y2, z2, then the position vector of A is Ra. Let me just check if the recording is on. Yes, it is on. So Ra, if we are given two vectors, 2 points A and B, then the vector corresponding to A is Ra and the vector corresponding to B is Rb. Then Ra vector is equal to x1, y1, z1, Rb is equal to x2, y2, z2, and AB vector is equal to Rb. AB vector will be the second one minus the first one, that is the head one minus the tail one. So we have Rb minus Ra equals to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Now distance and displacement. What is? So we have got, I hope you have understood this, AB vector. AB vector is Rb minus Ra vector. Simply the second one vector minus the first vector, the final vector minus the initial vector. So that is with the position vector and displacement vector. Now distance and displacement, what's the difference? Distance is the actual path covered by a moving particle or body in a given time interval. So suppose we are having a path from A to B, then to C. Then the distance is the actual path covered by a moving particle in given time interval. And displacement is the change in position vector, that is the vector joining the initial to final position. So AC is the displacement, that is given by delta R. Delta R I have written here. So S vector is equal to delta R is equal to RC minus RA vector will give us the displacement vector. Now moving on. Yes. Then average speed and average velocity. What is average speed? Average speed is the ratio of total distance traveled to total time taken. And average velocity is the ratio of total displacement to total time taken. Average velocity is equal to total distance by total time, and average velocity, average this is average speed. This is average speed. And this is average velocity. So we have average velocity is equal to total displacement. Mind you, this is displacement over total time, that is average velocity. Now instantaneous, moving on to instantaneous velocity and instantaneous speed. Instantaneous velocity and instantaneous speed are defined at a particular instant and is given by vi vector equal or v vector equals to limit delta t tends to 0 delta s vector by delta t or ds vector by dt or dr vector by dt. Here r is the position vector of the body at a general time t. Now magnitude of instantaneous velocity at any instant is called its instantaneous speed at that instant. So this is instantaneous speed. Magnitude. Magnitude, I'll use the highlighter. Magnitude of the instantaneous velocity at an instant is called its instantaneous speed at that instant. So instantaneous speed is equal to ds by dt whole mod. So there are these two mod symbols written here, which tells us that we have to take the modulus of ds by dt or dr by dt. Now average and instantaneous acceleration. Average acceleration is defined as the ratio of change in velocity. Average acceleration is change in velocity and it is given by delta v by delta t equals to vf by vi by delta t. And instantaneous acceleration is defined at a particular instant. It is defined at a particular instant and it is given by limit delta t tends to 0, delta v vector by delta t equals delta v by delta t. So that is how we calculate the instantaneous acceleration. Delta t is equals to 0 here. We have to remember this. So that was all for today, guys. If you have liked the video, please do like the video, subscribe to my channel and share it among your friends. Thank you.